So I got number 1 wrong. It says the train is at rest and inside the train a drone is on the floor. The train accelerates for some time and then the drone is brought to hover. What happens to the drone and why? So what will happen to the drone? It will once the train starts accelerating, it will move with the train because once the train is moving, all the air inside the train is gonna make the drone move with it forward, because the drone doesn't have the power to break all this air that's inside the train to move or stay at its original position. So that's why it's gonna move with the train. The second problem is a train is at rest and inside the train a drone is in the floor. The drone is brought to hover and then the train accelerates for some time. What happens to the drone and why? So this is basically the opposite as number 1A. So the drone is already in the air, then the train starts accelerating one way. Because the train is already in the air, it's part of the system, meaning that because it has enough power to break all the air and stay at its own position, it will break all the air to its right and stay at the same position, meaning it will fall back to the end of the train. The next one I got wrong was number 3, the one with the boat. It says the boy in the picture jumps horizontal from the boat, starting at v initial velocity and accelerating to final velocity in t seconds. If the boy is mass and the boat is m boat. Okay, so for the part A is asking us to draw a FBD. So this is how it's gonna look. Dot in the middle, one arrow going forward, up to represent buoyancy. Buoyancy because of the water. If it wasn't water and it was a surface, it would be F norm, but it's not because it's water. Then an arrow facing going downward to represent the weight of the kid. An arrow going right to represent the force of the boy on the boat. And then an arrow to the left to represent the force of the boat on the boy. That's part A. Part B is asking to if the boy has a mass of 20 kilograms and the boat has a mass of 25 kilograms, the boy jumps from the boat starting at rest and accelerating to 4 meters per second in 0.25 seconds. How far would the boat travel after 8 seconds, assuming the water is frictionless and the boat began from rest? Alright, so basically you treat this problem as 2 different problems, but you use the same equation. But first, the thing you have to find is the acceleration. So acceleration equals 4 meters per second, which is the final velocity over the time, which is 0.25 seconds, which equals 16 meters per second squared. That's your acceleration, which you're gonna use for the following formulas that we're gonna use. So first, 2 different problems, same equation, but different outcomes. So for the first problem, we're gonna cancel this one because we don't have the initial velocity. So well, we do have the initial velocity, but the initial velocity is 0. So it cancels out automatically. So we have left the change in x, which is the displacement, equals 1/2 acceleration times square. So 1/2, and we know the acceleration, it's 16 times 16 meters per second square, and it tells us that the time is 0.25 seconds square. When you do all the math, it should equal 0.5 meters, and that's the answer for the first problem. Now we go to the second problem. But for this problem, instead of canceling the first one, we're gonna cancel the second one. So the change of x equals initial velocity times time. The initial velocity is gonna be 8 meters per second square times the time, 7.75 seconds. 7.75 seconds because the problem is asking after 8 seconds, but then so you subtract 8 seconds minus 0.25 from the previous problem, from this problem, so it's 7.75 seconds. And after you multiply everything, the answer is going to be 62 meters. So now that you solve both of the problems, you add them together to find the displacement after 8 seconds. So 62 meters plus 0.5 meters equals 62.5 meters, and that's the answer. Moving on to the next problem, which is number 5. The last problem, it says a planet of radius r and mass m has an acceleration of gravity of ag. If the radius is quadruple but everything else held constant, what happens to the acceleration of the gravity? Show mathematical but use only variables and coefficients. Okay, so it's basically asking you to find the formula to find any kind of problem. So the formula will be so 5 acceleration equals the g constant, which is the same, times the mass of the planet divided by the radius of the planet square. That's the initial formula to any problem. But now this problem is asking what would happen if the radius was 4 times bigger. So we know the equation is this one. So if it was 4 times bigger, we will multiply the radius by 4. This is the radius, so by 4. So 4r squared. So our final equation will be acceleration equals g 4r squared. That's the final equation when the acceleration, when the radius of the planet is 4 times bigger. But now, it's also asked, it says what happens to the acceleration of the gravity. So now, using this same equation, the final equation, we use 4 squared equals 16. But what is 16? Well, 16 is the acceleration of gravity, meaning that the acceleration is gonna be reduced by a factor of 3. No, sorry, 16, which is the number we got over here from the equation. And that's it for all my text corrections. Thank you, bye.